All right. So the question asks you to use the mathematical rubric. Just in a second ago, we broke it into restating the question, answering the question, explaining the answer, and giving you an example. Then from there, we use mathematical vocab in this spot. What is some of the mathematical vocab we should be using in this question, which asks about choosing something fairly using probability? Maya?
Probability.
Probability should be in there. So, probability. Lulu would be another word, maybe. Fair. Good. I love how you guys are taking the words out of the question. Yes, Ben.
Theoretical.
Because theoretical probability is what this is talking about. That's how we know if something's fair. So, theoretical probability. Yeah?
Likely.
Okay. Put one word in front of that.
More.
Equally likely. So equally likely is going to be super important that we have. And what are we talking about when we say equally likely?
50-50 chance.
Okay.
Not all.
They don't, what? Okay, when you say they, what do you mean? What's the vocab?
Trials.
Outcomes. Nice, David. So there you go. That's good. So we have 5 pieces of vocab. If you're using 3 of them, you're doing a good job. But this is the vocab that should be in there. So Jacob, this is what I'm going to ask you. Check to see. Do I have these words in there? Did I say they instead of outcomes? Did I say chances? The chances are the same. That should be equally likely. And then the last thing is make sure you reread yours and that your grammar, spelling, and punctuation is fairly accurate. So who would like to restate the question? What'd you put down, Warren?
I put down when you choose something fairly using probability means that.
Nice. So instead of what, he just said when. When you choose something fairly using probability, that means, or it means. Okay, now someone answer that. What does it mean? Maya.
You calculate the probability and pick one that's.
Calculate the theoretical probability.
And try to pick the one that has the highest probability.
Well, if it's fair, will any of them have a higher probability than the others?
No.
No. So I calculate the theoretical probability for all of the outcomes. And my probability should tell me that they are all equally likely. That makes it a fair game. So sometimes using your vocab, you can kind of scaffold your explanation. So give me an example, because that's what we're on now. We explained it. We did the answer. We explained it. Now an example. What would be some examples? Yeah.
Maybe like getting pulled for a raffle and you have a 25% chance or 1/4 chance of winning.
Okay, so how would you have a 1/4 chance of winning?
By 4 people.
There's only 4 people. Bingo. Okay. And you have 4 cubes or 4 tickets, right? Reach in. Everyone has a 1/4 chance. Okay, all outcomes are equal. What would be another way? Yeah.
If there's an equal amount of blocks in a bucket and both are red and blue.
Okay, good. Yeah, having blocks, as long as you have the same amount for each color, it's going to be equally likely, right? And as long as it's random.
If you're like randomly selecting marbles and there's the same amount of each color, you have.
Bingo. Now, randomly selecting marbles, same of each color. What about a dice? Equally likely?
Unless
Are all outcomes equally likely? Yeah. Michaela? Okay. So I can have equally likely outcomes like a dice that are 1/6 of a chance. I could have the example where I'm flipping a coin. It could be 50-50, still equally likely. I could have a dreidel. You know those dreidels? Okay. Celebrate. They're used as a game during Hanukkah. Okay. There's 4. That's a 25% chance. Equally likely. Then one isn't more favored than another. Okay. So my favorable outcomes or my outcomes have to have a theoretical probability that is the same. It doesn't have to be 50-50. I don't want you to get confused about that. Could be 1/6. Could be 1/10.
1/6 billion.
Yes, it could be like the lotto, right? The Mega Millions, where you have like a 1 in...
36 million chance.
Oh, no, it's way beyond that. It's like 1 in like 250 million of a chance. But, hey, everyone has an equal chance, right? It's like no one is favored more or no number is favored more. Everyone has an equally likely chance to win that.
How many tickets can you buy? You can buy as many as you want.
As many as you want. You can buy as many tickets as you want.
Well, then it buy like 250 million tickets.
Yeah, and you still have a pretty high probability of losing.
Yeah, there's this one guy. He bought like so many tickets and he figured out the math, like where he had like a pretty good chance of winning. So then he bought that many tickets.
Well, if you buy a lot of tickets, you have
Your chances go up.
but it's not equally likely.
No, but each ticket is equally likely to win. It's just that you have a lot of independent, equally likely tickets. So your overall chances go up.
So it could be like 50 out of 250.
Yeah, exactly. Yeah. But remember, but each individual ticket is still only 1 out of 250 million.
Can you even buy 250 million?
Yeah, you'd be in line for a long time. I would like, you'd have to pull up a truck and it would have like all the ballot things.
Oh.
All right. Hey, just go over this. Put your warm-ups away. I want to make sure. Go for it. Look at that, James, huh? Way better than the old one.
Yeah, but this is like the 4th time I've He keeps making a hole.
All right. Just a reminder. No late work. This is 8th grade policy, starting you off. No late work. So you either do it or you don't, right? You don't get to make it up. So stay on top of it. Next one's a big one. Remember, you get a day for a day. My job, moving forward, isn't to tell you you missed school and you missed something in my class. That's not my job. That is your job. You missed school. You better go to your teachers and ask them, what did I miss? Do I owe you something? That is your job, guys. Okay, we have 84 students or whatever to worry about. You have yourself. So please take this, and I know there's going to be some learning curve here because this is a day for a day. I know all those track kids are gone. They missed school. I'm not going to remind one of them tomorrow that they owe me something. Okay, so that is their job now to take responsibility for this. I didn't get all your warm-up and exit tickets. That was a bummer. Grades are an infinite campus, and I can create and recognize a fair game. That's what we're working on today. That's why we talked about this, and that brought us there. I would like you guys to turn to page 59. It is problem 2 and 3. I want you to spend a little bit of time right now talking about 2. I don't want to worry about 3. 3, I think most of you guys got. But I want you to talk about 2. And then I'm going to be coming around and marking you up. Tomorrow, yeah. Because you missed Friday. Yeah, you did. I signed the homework on Friday. So if you were here on Friday, and I'm going to look here because I had written it down. Okay. It asks you to explain, so you get half credit. Got to be careful about the reading, but it's better than no credit. No? Yeah. No, that's not completed at. There was way more than just that. You got to take your time. Okay. Okay. Talk about it. Come on, guys. Good work.
And then there's a 2 7. I forgot.
Okay, no worry.
I said no because one.
I figured this pizza thing is about this is the same size as this hot dog one. So
Okay. It asks you to explain. I'll give you half credit.
For B, I said spinner egg. A ginormous. Oh my god, I literally said that. Good job, Jay. Hey, I want to come over here pretty soon. If this is
All right, so let's talk about okay. Let's make that the last one. Okay. Let's talk about 2 here. I have these 2 spinners. How do I compare 2 spinners? What is something that I need to do? Ben?
Like figure out like how many fractions.
How many pieces it really broken into? That is exactly it. So Jacob, here, because you're going to need to watch this because it's going to help you understand this problem. So Ben, say it again. What's the first thing I need to do if I'm going to compare things?
Break it up.
I need to figure out how can I break it up into the same fraction. So over here, what's the smallest area that's represented? Hot dog. Okay. So here, this is my smallest area. Do I know what proportion that is to the whole circle?
No.
No, not yet. So what do I need to do in order to figure out how many hot dog sections would fit in this? What would I need to do? Yeah.
measure the outside width
And then continue it, right? So how many of this area would fit into spaghetti? Good. Okay, pizza, hot dog, the same, right? What about lasagna? 3. And these aren't going to be perfect. Okay, what about hamburger?
2.
And what about pizza? What fraction did I just break that into? 12ths. So this means hot dog is 1/12 right there. How much of the circle does hot dog cover? 2/12, or 1/6 of it, right? Okay. I still can't compare it to this. Why? I haven't broken this one into 12ths. So whenever you have to compare like fractions, you know you need to have the same denominator, right?
I didn't do 12, I did 7.
Whoa, that's really hard, dude. Sevens? How do you do sevens? You're a magic maker. All right. So let's start looking at this. Ideally, if I can break this into 12ths, I can compare them. All right. Here I have it into, there's 1, 2, 3, and that means there would be 3 over here. So what is it currently broken into? 6. Can I break 6 into 12ths?
Yeah.
What do I do?
Add 4.
I divide them by 2, right? All right. So if this is already, if this is 1/6, that's 1/6, that's 1/6, that means I just take these and I break them into halves. Now, over here, this isn't broken into 6. These are broken into 4ths.
So you divide each one by 3.
I divide each one into 3.
Why not 2?
Because then,
Then you don't get 12.
so now I have this section right there is 1/12. So now I have this divided into 12ths, this divided into 12ths, and it all started from us saying, what's the smallest fraction represented here? We broke the rest of it into that same fraction. We came over here, we did the same. So now I actually can answer these questions because I can support my answer more than just saying, what's your favorite lunch is pizza? Well, Spinner B and A because they're the same amount. No, now I can actually say how much they are.
There's an even chance for all of them.
So how many 12ths does pizza have over here? 3 12ths. How much does pizza have over here? So I can say that spinner A has 3 12ths and spinner B has 3 12ths. So they are equally likely. Doesn't matter which one. They have the same amount of outcomes.
So you can say spinner B or spinner.
Yep. If your lunch is lasagna, you're like, yeah, lasagna.
Lasagna.
What am I going to choose?
Spinner A.
Spinner A. Why? Shh. Okay, that's because it has 3 12ths compared to 2 12ths. That's what I want you guys to use. When it says explain your reasoning, give some support. Your reasoning has to be more than just spinner A has more space. We're beyond that. You laugh, but I read a couple today, and that's what they said. Okay.
That's not what mine said.
You sure about that?
So,
7. You're great.
but he explained it using 7s, which was pretty impressive. Maybe not correct, but impressive. So spinner A has 3 12ths versus spinner B has 2 12ths. All right, what about hot dogs? Hot dogs. You love hot dogs. What are you going to choose, Lulu? Because?
I would
Is?
choose the hot dog.
They have a larger area.
Versus 3 over 12. Good. So, Lulu just explained, I would go with spinner B because it's 3 12ths versus over here 2 12ths. Isaac. Questions? Okay. You guys have you have today, I want you, before we start our work, this is just a tiny bit of learning, and then we're going to start our work because you don't need a lot because I've already front loaded a lot into this with equally likely. We are not at the beach, mister. Come on.
Yeah.
That would be pretty sweet if we were, but we're not. All
Came down.
right, so go ahead. Talk to your tables about this. Go. Talk at your tables.
When using cards, does it matter if I put the card
Yeah.
back to the deck?
I don't get. Yeah. I think it. Yeah, it does.
I'm confused. It does matter because
It changes the probability. Wait, when adding back in the day,
No. It wouldn't matter.
Well,
No, it wouldn't matter.
it would make it like.
Because it takes the card out.
It
It's
started
the same probability.
It started messing the whole thing up.
not necessarily.
You get the same probability.
It said if it put the card
For
back
each
in,
card.
Yeah, it
put
would
it
be
out.
the same
Took it
probability.
out.
If anything, if you took it out, it would mess it up.
If you put it in there.
No, if you did, if you put it in, it wouldn't matter.
would.
You started with that card.
All right. Here's some good discussion. So what? So, Ben. Ben has to choose one of these cards. What? Oh, it's on freeze. I thought it just wasn't. All right. So, Ben's got to choose one of these cards. So what are Ben's outcomes? What are his possible outcomes? Ace,
1, 2, 3, 4, 5, 6, 7, 8, 9,
king, queen.
10.
Okay. Great blackjack hand, by the way. All right, so
Oh, it's out of those.
Ben, pick one.
King.
So Ben's choosing a king, but you know what? He pulled out an ace. So what were his chances to get a king? His theoretical probability. 1/5. Is his game, is it random?
Yeah.
Totally. Okay. Do each of those have an equally likely chance?
Yeah.
Okay. So Ben doesn't get it. He puts his card back in. Now I go to Jacob. Jacob gets to pick one. Okay, I shuffle him up. Jacob goes to pick one. What are Jacob's chances that he's going to get the right card?
1/5.
1/5. So Jacob still has the same probability. So this is a fair game. But let's say we switch that. He chooses king. He pulls out the jack. He keeps the jack. Now I go to Jacob. And I say, and Jacob has, what are his outcomes?
Jack. Ace, king, queen, and 10.
So you would have a 25% chance.
So now Jacob has a 1 out of 4. He has a 0.25 or a 25% chance. Is this game fair?
No.
No. It is not fair.
I mean, between the possible outcomes.
Okay. Aha. Because here's the deal. In the original game, this one, where we put it back in, where we're putting the card back, this is an independent, guys, listen. This is an independent event that has a 1/5 chance. But if Ben doesn't put that back in, and I go to Jacob, this is also an independent event, but it's not the same probability. He has all equally likely outcomes, but
It's a greater chance.
he has a better chance, right? It's like he has a greater chance. So putting the card back makes it a fair game. Not putting it back does not make it a fair game, because as that game goes on, if you're later, you have a greater probability. You do not have the same probability. Yeah.
What's the goal of the game?
To do the other person's homework.
No.
Easy.
No, Ben says. So we're looking at this. I can create and recognize a fair game. Putting cards or taking something out and not putting it back into whatever it is that you're trying to figure out to make a decision is not going to be fair, because that probability is going to change and it's going to get higher. The chances of winning get better. If I was keeping the card out, do I want to go first, second, third, fourth, or fifth?
Yeah, you would go 100%.
I have a 100% chance of winning if I'm last. But does that mean someone in front of me still could win?
Yeah.
Yeah. I haven't done the study, but I'm curious to see. I don't think you'd want to be first because you're 20% chance.
I would do actually.
Then you're 25% chance. But then by your third, you are a 33% chance.
I would do because then it's like
You have a pretty good chance of getting it right. And no, I'd go first.
Oh, baby, because you're psychic.
I know where the cards are.
So today,
Wait, you're telling me FedEx?
here we go.
Oh my god.
Isaac. Today, this is your job. And I want you to listen because it's a little bit different than sometimes how we do this. 52, 53, that's your engagement. We have independent practice, 1A, 1C, 1D, 1E. Make sure you follow that. You don't need to do them all. I don't expect you, there's a bunch of them. I only want you to do those. And you need to be thinking about not just yourself in this game, but you need to read the top part. It talks about how many kids there are that are playing this game. So make sure you read the top part up above. Then you're going to go to 2, and then you're going to go to B. This is what you do independently. If you finish those, or when you do, you should, especially if you work hard. NPSS is your homework. That is your homework right there. So you get to start on this, then obviously put your name up there, and then when someone else picks you, then stop doing that, talk about B, and then start on C. C will take you a little bit of time. If you finish C, which a few kids have, a few partners have, then you go to D, D1, D2, D3, and that's pretty difficult too. Questions? All right, we have 20 minutes. Let's go. Isaac, that's going to be time, dude. Get to work. It's not social time. It's math time. So it means so they have, one day at school, Calvin's teacher has to decide which student to send to the office. He's got Billy, Evo, Carla. He has Billy, Eva, and Carla. There are 3 kids.
Wouldn't it be 3 because,
Huh?
or would it be 4?
No, it'd just be 3.
Wait, wouldn't it be 4 because of Calvin?
Could you do multiple coins or just one coin?
So it's asking for 1 coin. Now, so let's talk about the coin.
Oh,
That would only be for 2 people.
So the coin, now, right, because if there are 4 kids. Calvin, Evo, who are they? Billy and Carla. So we got 4 kids.
Calvin doesn't
Calvin
volunteer.
just
Calvin's not
suggests-
doing it. Calvin doesn't volunteer.
Okay, so 3 kids. All right. So there's 3 kids. If you were flipping a coin, would you want to go first, second, or third?
Third. Start.
Second because you have a 50% chance.
If you go first, don't you have a 50% chance going first?
Yeah.
If I want to do it, I'll go first. What would the spot I would not want to go? Last. Why?
Because you have a low likely chance.
Because either probably the first person or the second person are going to win. Right? Because there's only 2 outcomes on a coin. And if I go third, the probability of them winning is really high, one of them.
Yeah.
So now I couldn't use the dice that way or the coin that way. But what could I do that would make that fair? David?
So you could have 2 of the students flip a coin against each other, I guess, and then the winner of that game would flip against the third.
And maybe like the first one to get 3, they're out and you keep going, some sort of tournament play, kind of. Good, yeah. That could make flipping a coin fair. But if it's the first one to get heads, I want to go first. I got a 50-50 chance. Maya?
I did, like, for each student, you flip the coin once, and, if, like, whichever student got their desired result once, but if 2 of them got it, you do it again.
Good. So I could say, all right, what do you want? Heads, flip. Tails, you're out. And then James goes, up, heads, and then you go, and you get heads. She's saying, okay, then you tell me again until there's only 1 left. So it's a little bit of a tournament play too. Okay, good. Yeah. That makes it fair. But the first one to get heads wouldn't make it fair at all. What about colored cubes?
Or on the coin, couldn't you do like best, like 2 out of 3? So say you
Could, yeah. That's a little bit of a tournament play. As long as it's not the first one. Because if it is, I want to go first. If that's what I want to do. If I want to be the messenger. What about cubes?
yes.
A number cube?
No, we're not doing number cubes. That's B. We're doing C. Color cubes. How would color cubes be fair? Jacob, how would color cubes be fair?
Three colors and each same.
Yeah. So I could go 3 colors. Would it matter if I go first, second, or third?
Neither.
Not really, right?
You just have to figure.
As long as we do have the same probability. But it would be nice that if Ben got his right color on the first time, I get a chance to choose my color. And then we just keep going until somebody...
Like the dice thing that mine.
Exactly. Yeah. So you do have to think about what is fair, because a 33% chance, I still would want to choose my cube first. That's pretty good, 1 out of 3. Even though Ben has the same chance and Liam has the same chance, if it's the first one to get their color, I'm going first.
You're going down.
I'll go last, no solution.
All right, now that we've talked about that, that should help you guys with D and E, okay? All right.
Wait, is 2 asking about 8?
Yes, about, yeah,
The ones that we pick?
yeah. About what makes them fair. And I think we've discussed that, like tournament play would make it fair. As long as everyone still gets to pull a chance. There is one in there that is the spinner. You could, yeah, I'll let you talk about that. Where?
Should we put the whiteboard on freeze?
I'm just doing attendance. Which one are you on? Spinner. Yeah, think about how would you make that fair. Yeah, bingo. Still, even with the spinner, like, even if you cut it up and there was, I guess there's 3 kids, right? And it was broken into thirds, you'd still want, like, if I was last, I would still want a chance to spin, right? So it wouldn't be like first one to get it. Yeah, that would make it fair. But yeah, they would all have to have the same amount of space. Or the same probability.
Wait, does this deck have jokers or no?
You could say no joker, so it's 50, just 52, not 54.
Actually,
But you wouldn't have, you don't have to use the whole deck either.
yeah.
Yeah, no. Cam did the exact same thing. No, that it says which one would you choose. But question 3 is a different question. You'll see. But yeah. I mean, you go with Benno, right? You're like, dude, I love kickball. I'm gonna go with that one.
What kind of name is Benno?
I had a student I was over in Vienna. It was short. I'm trying to think of his formal name, but it was he was African. He came from South Africa. I don't think it's a very common name. About 1 more minute. 1 Minuten.
Are you gonna finish this one tomorrow?
Yeah, we're gonna work on it tomorrow. I expect, a lot of kids were gone today, but we'll see. I'm gonna definitely do D will be my warm up, I think. So. All right, go ahead, put that away. Your exit ticket. Oh. Hey, okay, Tuesday. I'm assigning this today. This is your reflection. This is due on Tuesday. So it was on Monday. Everything kind of got pushed back because of a couple different things. But, so I have it up right here on the board. It's assigned here. It's due on Tuesday. Wednesday we'll do a Socratic. So this, you got to have this done. James, Isaac, please. Partner quiz got moved from Wednesday to Thursday. So you have plenty of time to do this. Am I going to accept late work on this? No, 9. So, be on top of it. All right, that's pretty scary, Ben. All right,
They didn't see my face except on it.
Okay, problem 1 on page 58. This is your homework for tonight. Problem 1 on 58. We talked about creating and recognizing a fair game. We know that there are components to a fair game that must happen. Theoretical probability must be the same. All outcomes must be equally likely. And everyone must be able to participate. So it can't be like the first one. Everyone has an equal chance to participate. Oh my gosh. So, multiple choice. Jake, Carl, and John are deciding what to do after school. Jake thinks they should play video games. Carl wants to see a movie. And John thinks they should ride bikes. Which strategy is a fair way to decide? You need to pick one and then explain why.
Are you gonna do A, B, it's a multiple choice question. So you choose one. Oh.
Okay, go ahead, talk your tables. 30 seconds.
I said B because for each outcome, there's a 33% chance of each one.
So I'm going to go off what David was saying. David said B because I have a 33% chance to get a 1 or 2, 33% chance to get a 3 or 4, and the last one 5 or 6. So B would be the best, the fairest way to decide which one to do.
I would do C.
Yeah.
Yeah, I would go for like
Video game.
So, okay, hey,
I would do B.
remember your homework for tonight? Please stay on top of it. See you guys later. Have a good night.